So let's do question 2 now. For question 2, once again, I have a system of equations that I want to solve using substitution. I'm going to start by labeling my equations. So this will be equation 1. And I will label my second equation as equation 2. Due to equation 1 being x by itself, so remember I want to have either y by itself or x by itself before I substitute in. I can leave equation 1 alone and substitute it into equation 2. So plug equation 1 into equation 2. So let's write out equation 2. For equation 2, I have 3x plus 2y equals to negative 10. Okay, so since equation 1 equals to x, I would plug in everything that x would equal into equation 2. In this case, x equals to 3y minus 7. So I just plug that in for my value of x. So instead of 3x, it's now 3 times 3y minus 7. Now I write out the other terms. So 2y plus 2y equals 2 minus 10. Now I try to simplify. So because I have a 3 in front of the brackets now, I would multiply the 3 into the terms of the bracket. So it would be 3 multiplied into 3y and 3 multiplied into minus 7. So once I do that, I will get, 3 times 3 is 9, so that gets me 9y. And 3 times negative 7 is negative 21. So I got negative 21. And now I add my other terms that I didn't touch. So plus 2y equals to negative 10. Now I want to add up my like terms. So because 9y and 2y are like terms, I can add them together. So 9y plus 2y would be 11y. Now I have minus 21 equals to negative 10. Now I want to isolate y by itself so I can solve for it. So let's add 21 to both sides so we can cancel out the 21 on the left-hand side. And once we do that, we should be left with 11y on the left. And on the right-hand side, we should have negative 10 plus positive 21. So that should just be positive 11. Okay, now I'm just going to write 11y equals to 11 on this side. That's what we simplified to so far. So to isolate for y further, let's divide every term by 11. So I'm going to divide every term by 11. I'm doing that because 11 over 11 is 1. So that just leaves me with y by itself. And then 11 over 11, we can reduce that on the right-hand side to 1 because 11 over 11 is also 1. So y equals to 1. So once we found that y equals to 1, we found our value of y, let's plug that into either equation 1 or 2 to solve for x. In this case, since equation 1 looks like it's easier to plug into, I'm just going to plug y equals to 1 back into equation 1. So for equation 1, I have x equals to 3y minus 7. So if I plug in y equals to back into equation 1, y equals to 1, so I would just say 1 here for where y would have been. I would have put 1 instead. So now I have x equals to 3 times 1 minus 7. And if I simplify that down, 3 times 1 is 3. So I have 3 minus 7. So x equals to 3 minus 7, which should be minus 4. And those are my points of intersections. So I have y equals to 1 and x equals to negative 4. So my point of intersections, or my solution to the system of equations, is negative 4 and 1.